Let's take a look at some concepts regarding the equilibrium constant and the equilibrium expression. First, we want to look at a comparison of how k values relate to each other. So, these are three different situations of different values of k. So in the first example, we have a small value of k. So you can see that there's a very small amount of product and a very large amount of reactant. So very little reaction has occurred here. So we have mostly the blue, very little of the red here. On a large K, it's an opposite situation where you have a lot of product and very little of your reactant left at equilibrium. An intermediate case, so somewhere around 1, you would have about an equal amount, somewhere in that. So somewhere in between the two. So what I mean by a small k is less than 1. K's are always positive, but this one's going to be somewhere between 0 to 1. So something like 3 times 10 to the negative 4th. So often you'll see a negative exponent with these small k's. With large k's, you could be anywhere from, it's got to be over 1. But it could be something like, you could have 3,000. You could have 4 times 10 to the 12th. There's a lot of different values you could get for a large k versus small k. What's important is to realize the comparison. If your k is larger, then you have proportionally more product. So larger k, more product. And this is helpful because there's a variety of things that can be done and different types of reactions that create the same compounds. If you're looking to create or make a particular product, then you want to choose the type of reaction that's going to give you the most product for your reaction. So you want something that has a large K if you want to create that product. Some other things that we need to keep in mind with Ks, or with the equilibrium constant, we never include solids or liquids in K. So K, we're only working with something that has a physical state of being gaseous or aqueous. So you would expect it to be a gas or to be aqueous in the balanced equation. Solids and liquids, we don't have concentrations of those. Those aren't, they could still be limiting reactants, but they aren't involved in the equilibrium. Your K can be calculated based on concentrations or on pressures. A K based on concentration is sometimes written as Kc, a K based on pressure, Kp. The important thing to remember when you're doing these types of K calculations is that your units need to be consistent throughout. You can't change units halfway through. So if you're working with pressure and you're working with atmospheres, it has to be atmospheres the entire time. You can't go back and forth between atmospheres and millimeters of mercury and inches of mercury and expect to get an appropriate value.